I find drone swarms to be fascinating. But they're so expensive. I think it should be possible to make these a lot cheaper and to give people options to configure the drone so they only have to pay for what they need. I want to achieve this by making the drone efficient with less batteries, make it have thermal vision with less quality, but making it more usable by combining the thermal and the regular camera in one image, or by enabling it to zoom in on suspicious areas. And that is just the top of the iceberg on how I would like to achieve this. I have a lot of ideas for this drones, and it should be a great way for people to create drone swarms for much cheaper than is currently possible, or to just have a drone or buy a drone in general. The drones of this video are probably made for light shows, but I'm trying to focus more on search and rescue drone swarms or swarms for military purposes and potentially helping out Ukraine. There are hundreds of purposes for drones, so that's not the limitation here. On this channel, I want to take everyone along on this journey of engineering a drone and starting a drone brand. I'm only 19, but I'm very ambitious and I can learn quickly when it matters. And I think that showing everyone my progress can be inspiring, and it can give a better idea of what is there to come if anyone is thinking about starting a business or innovating something with no experience. In the first few months, we are going to be building the base of the drone with all of the technology required to fly in a drone swarm. There are several chapters that we need to think about. In this video, we're gonna go into picking the right airfoil and how I chose mine, picking an aerodynamic design for the overall drone, making that design work with a VTOL or quadcopter setup, and the process of making a CAD drawing so we can test the aerodynamics in the next video. Every week I'll be making an update video like this one, so welcome to week 1 of building a drone swarm. It's currently Wednesday, and the past days I've been researching a lot about aerodynamics. As you saw in this video, which is a very poorly made prototype by the way, it's more of a sketch really. But as you can see, my plan is to make it a VTOL drone that can fly vertically with wings. Obviously, having wings drastically improves how long it can fly, and as I want this drone swarm to be capable of doing search and rescue missions, a long flight time is super beneficial. This also means that less money has to be spent on these 4 motors, as they don't have to be super efficient in the first place, and this would leave more money for the main motor, which should be as efficient as can be. As I want the drone to have wings, I needed to think of what airfoil I'm going to use. If you're not familiar with planes, the airfoil is simply the shape of the wing, which is the main reason a plane can fly. You will get to know more about how this works in this video. There are many different shapes of airfoils. Every combination of thickness and the front and the back does something different. Here I'm finding out all of this and figuring out what the most optimal airfoil is for a plane that can fly at low speeds without stalling, and one that is also very efficient so it can glide for a long time. This saves power. NASA has a lot of information about this, and there's the added benefit of seeming extremely intelligent if someone walks in on you. I ended up using ChatGPT for answers I could not find on Google, as I found that ChatGPT is actually impressively good at giving straight up accurate answers, and I'm talking about GPT-4, maybe not GPT-3. You need to check your facts of course, but in general ChatGPT is extremely useful. It recommended me a good airfoil that I decided to test on airfoiltools.com, along with a few other airfoils, yeah. And I did find that the one GPT-4 gave me would actually be ideal for my drone. I decided to copy this airfoil in Blender and put it in this wind tunnel that I downloaded from some YouTuber. This wind tunnel is usually meant for like F1 cars, so the wind is definitely going to be quite fast, faster than I'm going to be flying, so take it with a grain of salt. Later in this video, I will be putting this in a proper wind tunnel, a simulated one, with my friend who soon has his automotive engineering degree and knows how to work well in SolidWorks. And if you don't know, SolidWorks is the industry standard for CAD drawings. Not CAT drawings, no, CAD drawings. You can also build like entire cars in there basically, or drones, and he's going to come in handy for this project. So shout out to you, Jordy. But back to the Blender wind tunnel, I put the wing in there and it gave me some pretty cool results. This really helped me understand how an airfoil really works. Blue dots mean fast wind and red dots mean slow wind. You can tell that most of the wind is directed to flow over the wing and then gets pushed downwards. And from my understanding, that's what pushes the wing and the plane upwards due to the pressure created here at this point. So, airfoil, check. Now let's think about the body of the plane. So at the beginning I saw some image of a VTOL drone looking like this, and I decided to copy it in Blender to make this cool animation. But to be honest, it looked ugly, and I thought this could be done better and more efficiently. Tuesday, me and my friend Jordy had a chat about this and we found this image of a drone. We thought this would be a lot better because a flying wing seems like it's efficient, which it sort of is. My friend Jordy started designing this plane, but in the meantime I was thinking a little and had some doubts on the aerodynamics of this. You see, planes like this with the V shape are great for flying at high speeds, but we're talking real fast speeds, like Mach 1, the speed of sound. Our drone won't be hitting that and nowhere close. In fact, it needs to be capable of going very slow, in order to be able to do search and rescue missions and other things. For slow speeds, the angle of the wings should not really be diagonal like that, but straight instead. Straight wings mean less agile, less fast, but more efficient. Just like a glider plane. I also saw how these old planes used to have tandem wings or even 3 wings. I did some research and it did actually increase lift, but it also created more drag. And the drag of a second wing was not worth the lift that it gained. But I wanted my drone to take off vertically, right? So I need to put those 4 motors somewhere eventually. What if there's a big wing in the back and a smaller wing in the front? More lift and more aerodynamic placement of the drone motors. That's when I found this design by some company. I thought this looked sexy as hell and it seemed more efficient. It turns out this drone was actually fully made for being efficient and still carrying a lot of weight. Perfect. So I copied this design, but then worse, in Blender. It was glitching out like crazy because I suck at Blender and I only learned how to use it like 2 weeks ago. But when I had the main model, I started adding a few holes in the wings and put some of the drone motors in them. It looked good. Sure, the drone motors would decrease aerodynamics somewhere, but they would have to regardless, so it's a good placement in my opinion. It's currently Wednesday and I did everything I just said in the first 2 days of this week. So please keep that in mind because I'm sure some of the information or assumptions that I made are extremely stupid. If so, please enlighten me in the comments and feel free to give me some feedback or tips for this drone as well. So, I emailed the pictures of this drone to my friend and sent the original drone, and let's see if he likes it too, and hopefully he will build a proper version of this in SolidWorks so we can test out the aerodynamics in their simulation. And if that's all good, I want to make a prototype with styrofoam and throw it off this hill and see how well it flies. I want to do this next week, but I'm not entirely sure if that's going to be possible. It's a bit too ambitious, I think, but I want to do it soon. But be sure you subscribe and hit that bell so you don't miss out on any of that. On the business side of things, I want to tell you a little bit more about why I want to do this. Currently, you see Ukraine use these a lot in war, and currently Europe is preparing a lot for war. So I think it's the perfect timing to have a sort of war-capable drone, but not specifically made for that. This is not going to be a war drone, okay? But along with that, I think a swarm of search and rescue drones could help people find someone or something way faster when time is the #1 priority. Sure, there's competition, but they're very expensive, and there are a lot of countries that just don't need all those small details that you get for such a price. That's why I want to have configurable drones and make all drones modular so they can be upgraded in the future. These are currently the 2 biggest reasons for doing this, but there are so many other purposes for drones that are good that I could not even fit in this video. My brain is an endless flow of ideas, and my dad's brain too. He came up with the idea to hang a metal detector underneath the drone to find and map minefields. I don't know if this exists already, but it sounds quite smart. Considering my age, I don't have infinite money sadly. I have enough money to make prototypes, but I do have to save up for some of the expensive bits, which could slow down the progress, and I hope to earn some money from this YouTube channel to be able to speed up the process. If you would like to donate anything, I put my PayPal in the description, or if you are good with drones or with software development or anything else that is of use and you want to help me out a little, that would be amazing too, honestly. My email's in the description. So, drone body, check. And VTOL setup, sort of check. We still need to figure out how exactly we will place the motors in the wing and what we can do to make it as aerodynamic as possible. But before we can do that, which motors do I use? It is currently Friday, and I'm going to do research on how I should pick my motors and which ones I should pick right now. And I will record it so I can take you along on how I go about learning things. I already figured out that drone motors always have a kV rating, which everyone seems to look at. kV is a measurement on how fast a motor spins on a certain amount of voltage. For example, 1400 kV means the motor spins at 1400 RPM when it is given 1 volt. But to me, this did not mean much. If I want to lift a heavy drone, I would need a motor that puts out a lot of thrust. And more RPM doesn't have to mean more thrust. In fact, when I looked up what a good kV is for a heavy drone, I was recommended something between 400 and 800 kV, which is quite low compared to what I saw online. There is no easy way to tell how much thrust a drone motor can generate, because it depends on how much volts you give it and what propeller it is. I estimated my drone would be 15 kilograms at most. This is a very rough estimation I made without any proper reasoning. I also was not sure yet if I was gonna make the body 3D printed or if it was better to make it out of styrofoam and add a coating to make it weatherproof. For the first prototypes, I was definitely going to take that route as it was also way cheaper. And the more I look at the motor requirements, the more I consider using that on the final production versions as well, but still leaving the option open for customers that wanted 3D printed or plastic body. For styrofoam bodies, 15 kilograms was way more than necessary though, and I will find that out later. Right now, as I'm recording this voiceover, I'm really cringing at myself, but I'm gonna show all of you my learning process. 15 kilograms was overkill, let me just tell you that. So first I wanted to figure out how many propellers would be most efficient. It was hard to find a clear answer as just like all of the other properties, this heavily depended on the many other configuration choices that you can make. But I stuck with 2 as that seemed most likely to work out well as most drones had 2 propellers. As there were no simpler or clear answers online to what motor I will need, and even ChatGPT could not give me a simple answer, I realized that such an answer isn't even possible, and I found this website where you have to add all of the characteristics of the motor, props, battery, etc., and it runs a simulation to see how good the configuration is. So I started working from top to bottom and figuring out what all of this meant. So I temporarily added the 15 kilogram drone weight in there, along with the 4 rotors as I'm just trying to find out what VTOL motors I should use. I wasn't sure on my frame size yet, so I just put 2 meters, which looking back at it now is not accurate at all. It should be way smaller, but we have to measure that properly when we finish the CAD drawing. I had to figure out what most of these numbers even meant, and it is probably too much to all fit in this video, so I will go over it quickly. I couldn't figure out what field elevation would mean exactly, so I decided to skip that and just leave it at the default values. The pressure was apparently the air pressure in your specific location, so I looked it up real quick and found it luckily. Apparently this is a very detailed simulation if you have to enter the air pressure. Onto the battery, I always thought lithium ion was more energy dense, and that's true, but the power to weight ratio is better on LiPo batteries, so I will probably be using that instead. So I went on AliExpress because they're cheap, and I found these 6000 mAh batteries. I had to figure out what all of the metrics meant of like 120C and 3S, 1P, etc. Apparently 120C is the rating of how fast it can discharge. 3S means 3 series and 1P means 1 parallel row. I entered the cheapest option first, but later on I had to switch it to the 4S 1P version because otherwise it would not even hover. And obviously I will need more milliamps in the future, but I'm just looking for a cheap way to test out the drone and get a better feel of what the cost will be. Then I had a look at what controller I needed. I didn't pick one as I heard you just have to make sure that the amps is enough, so I calculated what I needed for 5 motors and a 25% excess for safety. Then I added in these motors I found on AliExpress, and I asked ChatGPT what kind of propellers would work well with the current setup. I just copied and pasted everything that was in here, and ChatGPT knew all it needed to actually give a fairly good result, which I realized when I played around in the numbers myself. After I hit calculate, I saw that the drone wouldn't even be able to hover. I messed around with a few settings and other motors till I realized that this was never gonna lift 15 kilograms. So I dialed it down to 500 grams to see what that would do. And after messing around with a few different motor options around the same price point, I found a configuration with a 5:1 thrust ratio on these 500 grams, meaning that it could lift itself 5 times. But to be fair, the components I added in alone would weigh more than the 500 grams, so yeah. To make a drone controllable, it needs a thrust to weight ratio of at least 2:1. And of course I want to be able to carry payloads later on, so I will have to keep that in mind as well. I messed around with the different configurations a bit, and the best thing that I could come up with was a 1.9 thrust to weight ratio with an 8.8 minute flight time if the drone would weigh 3.5 kilos. There are so many different configurations that I will just make a Excel sheet off camera where I document a bunch of different combinations until I find a good one, but your recommendations would help out a lot for sure. I will show you what I came up with next week, but it's time to move on to the CAD drawings. By the way, I also made a slightly better estimation of like what the drone would weigh by dragging this kind of scale model in like my 3D printer software. And it was 10 times smaller, so I just put that in and it said 100 grams of filament was needed. So I just did that times 10 for the realistic size, and that would mean that it would weigh 1 kilogram. But of course this is not the finished like drone, so it's hard to tell. I will show you what I came up with next week, but it's time to move on to the CAD drawings. We will not make holes yet for the motors until we find out which ones exactly. So for the CAD drawings, there's not a lot to be said just yet. I sent all the prototypes and measurements to my friend, and he's working on it, and here's a few sneak peeks that he sent from his phone. But it's not finished yet, and he's continuing to work on that right now. Next week I hope it's going to be finished, and then we can put it in the SolidWorks wind tunnel, but for right now we're going to have to leave it like that, so I will have to update you on the next video. That was it for this week's video. Let me know if you like the way that I'm documenting this. I'm sorry if there's a lot of misinformation that I put in here. Don't use me as a way to learn, because I'm learning. And be sure to subscribe if you want to see everything we're going to do next week. Alright, see ya.